Today we're testing this custom loop that I built in the NZXT H1. Now, if you missed the initial video where I kind of explained how this was possible and how we built it, then I will leave a link to that down below. But to get you guys up to speed, I replaced the pre-installed 140mm AIO with a aftermarket 140mm radiator, and then hooked that up to an RTX 2070 Super and Ryzen 3950X. Most of the comments and questions that you guys had were of course on the thermal performance and whether that single radiator is enough to run both of those components. So that's mainly what we're going to be taking a look at today, and I'm also going to talk about whether I even recommend someone do this, and if I had to do it again, what things I would change. So the goal here was to just simply see whether building a custom loop in the NZXT H1 was even possible in the first place. And although this was definitely my most difficult custom loop yet, it can be done and easily replicated. But seeing as this is part 2, let's skip all of that and just jump straight to the thermal performance. And let's start with the CPU. I did a video recently on the Ryzen 3950X talking about how it can be cooled sufficiently with some low profile coolers, so a 140mm radiator really is no problem for this CPU. With all 16 cores pushed to 100% usage in a Blender render, the CPU averages out to around 71 degrees C after 30 minutes, lifting the radiator fan speed from 1250 RPM up to 1650 RPM. Didn't see that much of an improvement here, only around 3 degrees. So for sustained workloads, you're much better off with that quieter operation. So no problems with that CPU at all, but that GPU is dumping a lot more heat into the loop. At stock, with the fan speed at a fairly low 1250 RPM, the RTX 2070 Super levels out to 71 degrees C. Although that is fairly warm, that's still within a safe range and a big improvement in terms of noise levels compared to running the card on air. When we raise the fan speed up to a more audible 1650 RPM, we can improve that by around 7 degrees C, and this just shows how much heat is being soaked up by that 140mm radiator. Now, something that most of you guys know I'm a big advocate of doing for pretty much any gaming build, but especially ITX builds, is GPU undervolting. By reducing the amount of voltage that the GPU runs at, it's now producing far less power and heat. Here we can get one of the biggest improvements in GPU undervolting that I've personally seen. Now the RTX 2070 Super runs at just 55C and also at only 1250 RPM. That's a massive 16 degrees C improvement while only running 50 MHz slower. Not to mention pulling over 60 watts less power from 200 watts down to around 135 watts. Now, something that I do want to stress is that when both the CPU and GPU are loaded at the same time in game, an undervolt on that GPU is highly recommended. Without that GPU undervolt, you're going to be significantly increasing the amount of heat in the radiator and then in turn the temperature of the coolant and then CPU thermals. So without the GPU undervolt, there were times where I saw the CPU temperature spike above 85 degrees C while gaming, but with it, the CPU happily sits between 60 and 70 degrees C. If you're interested in learning how to do this, I do have a pretty easy guide to follow down below. It shouldn't take you more than 5 minutes. So these stats that you see here are all while running that GPU undervolt and with the single fan spinning at just 1250 RPM, and that made for a very quiet and cool gaming experience. Overall, those CPU and GPU thermals are pretty impressive and well within a safe range. Here's an idea of what you can expect in terms of noise levels. So I think CPU and GPU thermals are pretty much what most people would have expected with a single 140mm radiator, and since we're just using a single 140mm fan, noise levels are pretty good as well. But now let's talk about what I would have done differently if I had to do this all over again. And the first thing would be using much thinner tubing. Instead of using the 16mm tubing that I've got in there at the moment, I instead use 13mm, which would make it a lot easier to route the tubing through small gaps. It would also mean that I could use smaller diameter fittings, which, believe it or not, does make a difference in a build like this. And for those of you wondering if you should do the same thing and follow suit with a completely custom loop in the NZXT H1, I think if you've already got an NZXT H1 up and running or on the way, definitely consider doing this down the road and leave it on the table as an option. It's completely doable if you just follow the same sort of steps that I've done here. The hardest part for me was kind of figuring out how to build it, not actually building it, if that makes sense. So CPU and GPU thermals are definitely capable depending on what components you're using and if you're prepared to undervolt, but overall I think this is one of the coolest looking builds that I've done. If however you do want to maximize cooling and minimize noise levels in a similar sized case and you are prepared to build a custom loop, you would be better off with an N-case M1, because as opposed to a single 140mm radiator in the H1, you can fit two 240mm radiators in the N-case, and that's something that we'll be doing quite soon. I know I've been teasing that build for quite a while now, but I finally have the radiators here that I want to use, so that project has the green light. So this pretty much concludes the NZXT H1 custom loop. I'm still going to be using my slightly more compact but better space optimized build in the T1, seeing as that has better noise and thermal performance, but this is definitely a build that I can recommend to you guys in a hopefully more accessible case once NZXT finally get more stock. So if you are interested in doing something similar, or maybe you want to rewatch the build process of the initial video, I will leave links down below for everything that you guys need. As always, a huge thanks for watching, and I'll see you all in the next one.